Today we're going to be talking about the Pythagorean Theorem. The Pythagorean Theorem deals with talking about a very important shape. That shape is a right triangle. A right triangle is a triangle such that it has three sides, and two of the sides make up a right angle, or 90 degrees. The two sides that make up the right angle are called the legs of the right triangle. So these two sides are called the legs. This side, opposite the right angle, see how they're opposite, is always going to be the longest side. Has to be the longest side. This is going to be very important later on. We call this side the hypotenuse. You'll see this Pythagorean theorem throughout your math career. And it's something that becomes very important when you talk about trigonometry, when you talk about geometry, as well as when you go into some applications. So we're going to get down to the nuts and bolts of it. What is the Pythagorean theorem? The Pythagorean theorem says if we have two sides, A and B, that are the lengths of the legs, so leg 1 and leg 2, doesn't matter which is A and B, but A and B are our legs, and C is the hypotenuse, then this very basic equation will always hold true. A squared plus B squared equals C squared. You might have seen this before. Okay? So let's move on and try some problems here. Let's find the missing value. So we know two sides, 5 and 12, and this side here is C. Now they didn't have to tell us it was C because it's opposite our right angle right here. So if we want to find C, then these two sides must be A and B. Now when you're trying to determine which is which, in the end it doesn't really matter because up here you see A squared plus B squared equals C squared. So if we're adding, it doesn't matter what order we add in. Okay? So what we're going to do is, just to start on this first one, we're going to write down the Pythagorean theorem. A squared plus B squared equals C squared. And we're going to plug in. For this example, let's let A equal 5 and B equal 12. So 5 squared plus 12 squared better equal this missing side, or C squared. Now we have to follow our orders of operation. 5 squared is 25 plus 144 better equal C squared. 25 plus 144 is 169 equals C squared. And to get rid of squaring something, like we've learned in previous sections, we take the square root of both sides. So the square root of 169 equals the square root of C squared. The square and the square root undo each other, and we're left with C. Now the square root of 169 is in fact 13. Now if you remember, a lot of times when we were solving things where we had a squared variable, we put plus or minus in front. But in this case, you notice we didn't, and here's why. C represents a side of a right triangle, so whenever we deal with the Pythagorean theorem, C will always be positive. A and B will also be positive because they have to be sides, and sides must be positive lengths. So in these cases, whenever we take the square root, we do not have to worry about the plus or minus. Let's try another example. In example 2, we have B that we're missing. Well, which side's the longest side? Well, here's our right angle. This side opposite must be C. So let's label this one as A. So A squared, or 8 squared, plus B squared equals C squared, or 10 squared. 64 plus B squared equals 100. If we subtract 64 from both sides, we get B squared equals 36. And then if we take the square root of both sides, the square root of B squared equals the square root of 36. The square root of B squared becomes B, and the square root of 36 is a nice perfect square. So B turns out to equal 6. Again, we don't have to worry about plus or minus because B is the length of a side. That's not too bad. It's great when our numbers turn out to be nice numbers, perfect square numbers. Let's try another one. How about this one here? Again, we don't know C, so one of these is A and one of them is B. It doesn't matter which. I'm just going to label this side A and this 6 side as B. So 9 squared plus 6 squared equals C squared. 9 squared is 81. 6 squared is 36 equals C squared. We add 81 and 36. We get 117 equals c squared. If we take the square root of both sides, the square root of 117 equals the square root of c squared. That means that c equals the square root of 117, which is not a perfect square. But from previous sections, we want to look to see if we can split this apart. Are there any factors of 117 that are perfect squares? Yes. 117 is really 9 times 13. We just have to remember that it's the square root of 9 times the square root of 13 gives you the square root of 117. And since we can take the square root of 9, our final answer is 3 square roots of 13 equals c. We always want to give what's called the simplest radical form answer, which is not the square root of 117, it's 3 square roots of 13. How about one more of these? Again, we're missing a this time. One of these is b, one of them is c. The question is which? Well, the longest side is always c. Well, we can easily see that the longest side is 9. So it's labeled 9 as c and 4 as b. So a squared plus 4 squared equals 9 squared. A squared plus 4 squared is 16 equals 81. If we subtract 16 from both sides, we get a squared equals 65. And we take the square root of both sides. The square root of a squared equals the square root of 65. Or a equals, now can you split 65 apart? We can only break 65 into 5 and 13, neither of which is a perfect square, so that we have to leave it as the square root of 65. And those are some examples where we can use the Pythagorean theorem to come up with some missing values of a right triangle's sides. But what about its converse? Well, all the Pythagorean converse says is if we know 3 sides, if those 3 sides of a triangle satisfy the Pythagorean theorem, that then tells us that those 3 sides make up a right triangle. So if we're given sides 13, 5, and 8, we want to know if those sides represent the sides of a right triangle. Well, let's try this out. The first thing we really need to know is which is side C. That's the most important. And right here it says the side C is always the largest side. In this case, that's 13. A and B doesn't matter which is which, so I'm just going to label A as 5 and B as 8. So let's see if A squared plus B squared does in fact equal C squared in this case. So does 5 squared plus 8 squared, does that, and I'm going to put a question mark because we don't know, does that equal 13 squared? Well, 13 squared is 169. 8 squared is 64. 5 squared is 25. If I add 25 and 64, I get 89. Does that equal 169? It does not. What that tells us is these 3 sides are not sides of a right triangle. So these are not sides of a right triangle. Last one. How about 5, 13, and 12? Now, again, we need to determine which side is C because it has to be the longest. When we look at this, it's very easy to see that side C has to be that 13 again. In this case, it doesn't matter which is A and which is B. B could be bigger than A or A could be bigger than B. So, does A squared plus B squared equal C squared? Let's plug in. Does 5 squared plus 12 squared, does that, and I put a question mark here, does that equal 13 squared? Well, 25 plus 144, 13 is 169. 25 plus 144 is in fact 169. Does 169 equal 169? That's a silly question. Of course it does. So because A squared plus B squared equals C squared, because those values make the Pythagorean theorem true, these are sides. These are sides of a right triangle. And you're going to see some problems tonight that deal with these. Good luck, and please make sure your instructor knows if you have any questions.